This video is for Ibdp AAHL integrations topic, and the subtopic is going to be what is this further substitution. So the first 10 marks questions without GDC. So he's asking us to find the use the differentiation and integration formulas from the formula booklet to find 5 power x. We know a power x integral of a power x is a power x upon ln a plus c. So 5 power x integral will become 5 power x upon ln 5 plus c. So 5 power x upon ln 5 plus c. Now x power 3 integral is nothing but how much? It is x power 4 upon 4 plus 3 power x integral is 3 power x upon ln 3 plus c. Secant square x integral formula booklet tan x plus c. Tan square x plus 1 can be written as secant square x dx. Secant square x again is nothing but what? Tan x plus c. This is 5 upon cos square x. Numbers pull outside. 1 upon cos square x is secant square x dx. Secant square x integral is nothing but what? Tan x plus c. Cosecant square x integral from the formula booklet minus cotangent x plus c. Then cot square x plus 1 is nothing but what? Cosecant square x dx. So cosecant square x integral is minus cot x plus c. Now this is 5, number pull outside. 1 upon cos square x is cosecant square x dx. Cosecant square x integral is nothing but what? Minus cot x plus c. Secant x tan x integral is secant x plus c. And cosecant x cot x integral is minus cosecant x plus c. This is going to be the answer. Now coming to the next one. Use the formula 1 upon a square plus x square equals to 1 upon a tan inverse x upon a. 1 upon a tan inverse x upon a. So over here it is 7 upon 4 square plus x square. So a value is 4. So 1 upon a 7 upon 4 tan inverse x upon 4 plus c. Now for this one it is integral 7 upon 1 square plus 16x can be written as 4x whole square. So it is 1 upon a, which is 7 upon 1, then tan inverse 4x upon 1 plus c. But the most important thing is chain rule, 4x derivative 4. So don't forget to divide by 4. So again this can be written as 7 upon 5 square plus 4x whole square. So dx, this should be written as 1 upon a tan inverse, 7 is there as it is, so 7 upon 5 tan inverse 4x upon 5 plus c. Again chain rule, 4x derivative is 4, so divide by 4. Next it becomes integral 7 upon square root of 2 whole square plus x square. So it becomes 1 upon a tan inverse x upon a plus c. Over here again 7 upon square root of 2 whole square and square root of 3x whole square dx. So it becomes 1 upon a tan inverse x, which is square root of 3 x upon a, and square root of 3x derivative is root 3, so don't forget to divide by root 3, and plus c. Now for the third one, use the formula 1 upon square root of a square minus x square equals to sine inverse of x upon a. So over a is 4 square, over here it is integral of 7 divided by square root of 4 square minus x square dx. So it is sine inverse of x upon 4, and 7 is there as it is. Now this time it will become 7 integral of 1 upon square root of 1 minus 4x whole square dx. So it becomes 7 sine inverse of 4x upon 1. But again 4x is there, so divided by 4. Now this becomes 7 integral of 1 upon square root of 5 square minus 4x whole square dx. 7 sine inverse of 4x upon 5. But again I have 4x over here, so divided by 4. Instead of x it is 4x, so divide by 4. Next it is 7 integral of 1 upon square root of 2 whole square minus x square dx. So 7 sine inverse of x upon square root 2 plus c. Don't forget to write plus c in either all the cases. Then next it is going to be 7 outside, 1 upon square root of 2 whole square minus root 3x whole square dx. So it becomes 7 upon sine inverse of square root of 3x upon root 2 plus c. But instead of x I have root 3x, so divided by root 3. Now question number 4. Factorize x square minus 10x and express this as partial fractions. So 2 upon part A, 2 upon x square minus 10x plus 24 can be written as 2 upon x minus 6 times x minus 4. So which is a upon x minus 6 plus b upon x minus 4. So 2 equals to a times x minus 4 plus b times x minus 6. Now plug in x equals to 6. So 2 equals to 2a. So a equals to 1. Plug in x equals to 4. 2 equals to minus 2b. b equals to negative 1. So what will be the partial fractions now? 1 upon x minus 6 minus 1 upon x minus 4. Part B, x square minus 10x plus 25. This can be written as x minus 5 whole square. Part C, x square minus 10x plus 26 can be written as x square minus 10x plus 25 plus 1. Till 25 is x minus 5 whole square plus 1. Now coming to part D, D1, integral of 2 upon x square minus 10x plus 24 dx. So it is integral of 1 upon x minus 6 minus 1 upon x minus 4 dx. So which is ln x minus 6 minus ln x minus 4 plus c. For part 2, integral of 2 upon x square minus 10x plus 25 dx. So it is integral of 2 upon x minus 5 whole square dx, which is minus 2 upon x minus 5 plus c. And for part 3, integral of 2 upon x square minus 10x plus 26 dx. So it is integral 2 upon x minus 5 whole square plus 1. So this is the question in the second formula. So 1 upon a tan inverse x upon a, tan inverse x upon a plus c. Question number 5. What am I going to do? I am going to separate into 3. Integral of e power 3x upon 3e power 2x dx plus integral 2e power x upon 3e power 2x dx plus integral 4 upon 3e power 2x dx. So it will become 1 upon 3 e power x dx plus 2 upon 3 e power minus x dx plus 4 upon 3 e power negative 2x dx. So it will become 1 upon 3 e power x minus 2 upon 3 e power minus x, then minus 4 upon 3 e power negative 2x divided by negative 2 plus c. So my final answer is going to be 1 upon 3 e power x minus 2 upon 3 e power negative x minus 2 upon 3 e power negative 2x plus c. For part 2, it is 4 power x upon 2 power x. 4 power x can be written as 2 power 2x upon 2 power x dx plus 2 power x upon 2 power x dx plus 1 upon 2 power x dx. So what does that becomes now? It becomes integral of 2 power x dx plus integral of 1 dx plus integral of 2 power minus x dx. So my final answer is going to be 2 power x upon ln 2 plus x, then minus 2 power minus x upon ln 2 plus c. Question number 6. Use the appropriate trigonometric identities to modify and hence find the integrals. So integral of tan square x dx can be written as integral of secant square x minus 1. So what is integral of secant square x? Tan x. Minus 1 integral is minus x plus c. Now integral of cot square x. Cot square x can be written as cosecant square x minus 1. So cosecant square x is minus cot x. Then minus x plus c. Question number 7. Find the integral of this. So we have 3 upon x square plus a square. So it is 1 upon a tan inverse x upon a plus c. So it's going to be tan inverse x upon 3 plus c. For part 2, 3 outside, 1 upon 3x whole square plus 1 square dx. So this is 3 times 1 upon a, tan inverse a is 1. A is 1, tan inverse x upon x is 3x upon a. But chain rule, don't forget to divide by 3 because 3x derivative is 3. Now 3 gets cancelled. So what do I get it out just? Tan inverse of 3x plus c. Question number 8. Numbers pull outside. Integral of 1 upon square root of 3 square minus x square. This is sine inverse formula. Sine inverse x upon 3 plus c. Next one will be integral 3 outside 1 upon square root of 1 minus 3x whole square dx. So it is 3 sine inverse of x upon a. But don't forget to divide by 3 because of this 3x. Then plus c. That's going to be the answer. So 3 gets cancelled. So what does that becomes? Sine inverse of 3x plus c. Question number 9. Now again the formula for this one is 1 upon x square plus a square dx, which is 1 upon a tan inverse of x upon a plus c. So based on that formula, so what does it become? 7 upon this 4 can be written as 2 square. So 7 upon 2 tan inverse of x minus 1 upon 2 plus c. Now the next one will become integral 7 upon 2 times x minus 1 whole square plus 1 square. So it will become 7 upon 1 tan inverse of 2 times of x minus 1 divided by 1 plus c, but because of this 2x, don't forget to divide by 2. Now for this one, the formula will be integral of 1 upon square root of a square minus x square is sine inverse of x upon a. So 4 is 2 square. So it will become 7 upon 7 sine inverse of x minus 1 upon 2 plus c. That is the first one. For the second one, it will be integral 7 upon square root of 1 square minus 2 times of x minus 1 whole square. So it will become sine inverse of 2 times of x minus 1 upon 1, and because of this 2x, divide by 2 plus c. Question number 11. Find the integrals of this one. A upon bx square plus c. So what do? This is a tricky question. A upon, I take b common. So what am I going to do? Divide the numerator by b and denominator by b. C upon b. So it becomes a upon b is a number outside 1 upon x square plus c upon b dx. So what does that becomes? So let me write neatly so that I can create a space for this one. So integral of a upon bx square plus c. So what am I doing? Dividing numerator with b, denominator with b. So a upon b is a number, it is written outside. So 1 upon x square. C upon b can be written as square root of c upon b whole square dx. So this is in the form of tan inverse formula. So what does that becomes? A upon b times 1 upon square root of c upon b, 1 upon a, tan inverse x upon a, x upon square root of c upon b, plus some other constant, maybe k, because already c has been used. So my final answer will be, when I simplify this one, a upon b times root b upon root c, then tan inverse root b upon root c, x plus k. So b and b gets cancels. So what does that becomes? Root b and b gets cancels. One more root b will be left over. So a upon root bc tan inverse root b upon root c, x plus k. So be very careful with these roots. Now coming to the second one. So it is integral of a upon square root of c minus, we can do it out over here, square root of b x whole square dx. Rather than dividing it out, this is the easiest method. So what I will be doing it out, it is sine inverse square root of bx upon, this is also root c whole square, upon root c plus some other constant k. But instead of b, instead of x, it is root bx, so 1 upon root b, and a is already waiting outside, so a upon root b. So that should be the way of doing the sum. The same thing, instead of dividing this b also, I can do this part also. I am erasing this part, and you can see that you will be getting the same answer if at all you do by this method. What is that one? A upon, it can be written as square root of bx whole square plus square root of c whole square. This is the easiest way. So it will become 1 upon a tan inverse square root of bx upon square root of c, and because of this square root of bx, one more square root of b will be there. So you can see that within one step you get the same answer. Question number 12. Show that this entire left hand side equals to right hand side. So I take the right hand side, make the common denominator. Common denominator is x times x plus 2 whole square. So 3 times x plus 2 whole square minus 2 times x times 1 x plus 2 minus 5 times x. So what does it becomes? It becomes 3 times 3x square plus 12x plus 12, I expanded, minus 2x square minus 4x minus 5x divided by x times x plus 2 whole square. So we can clearly see that it becomes x square plus 3x plus 12 divided by x times x plus 2 whole square. That's going to be the answer. So coming to the next question. Now hence find the integral of this one. So what am I going to do? So integral of that one will be the integral of 3 upon x minus 2 upon x plus 2 minus 5 upon x plus 2 whole square. So 3 upon x integral is nothing but what? 3 ln x. Minus 2 upon x plus 2 is 2 ln x plus 2. Then plus minus 5 x plus 2 whole to the power of negative 1 upon negative 1 plus c. So when I simplify that, what should be my final answer? 3 ln of x minus 2 ln of x plus 2 plus 5 upon x plus 2 plus c. That's going to be the answer. Now question number 13. Calculate the integral of this. So what am I going to do? I am going to factorize x square plus 6x plus 8. It can be written as x plus 2 times x plus 4. So what does that becomes? Partial fractions for that. First I have to do the homework. 6 upon x square plus 6x plus 8 equals to a upon x plus 2 plus b upon x plus 4. So 6 equals to a times x plus 4 plus b times x plus 2. Then I plug in x equals to negative 2. So 6 equals to 2a. So a equals to 3. Then I plug in x equals to negative 4. So 6 equals to negative 2b. b equals to negative 3. So what will be this now? It will become integral of 3 upon x plus 2 minus 3 upon x plus 4 dx. So it is 3 ln of x plus 2 minus 3 ln of x plus 4 plus c. Further you can simplify 3 ln of x plus 2 divided by x plus 4 plus c. Now question number 14. Now this we cannot factorize it out. So x square plus 6x square plus 6x plus 13 can be written as x plus 3 whole square. X plus 3 whole square will become 9. 9 plus 4. So x plus 3 whole square plus 4. So what is this will become now? Integral of 6 upon x plus 3 whole square plus 4 dx. So what is the formula I'm going to use? 1 upon x square plus a square dx is 1 upon a tan inverse x upon a plus c. So over here 6 upon a value is 2 because 2 square. 4 can be written as 2 square. Tan inverse x plus 3 upon a. So what's going to be the final answer? 3 tan inverse x plus 3 upon 2 plus c. Now calculate the integral for this one. Now what is the case is x square minus 6x plus 8. X square minus 6x plus 8. It can be factorized into x minus 2 times x minus 4. How do I know? How should I be knowing whether it can be factorized or it cannot be factorized? For this one, x square minus 6x plus 8, first find b square minus 4ac. b square minus 4ac, which is 6 square minus 4 times 1 times 8, which is greater than 0. So they will have two roots. So what are those two roots? X minus 2 times x minus 4. Previously, b square minus 4ac, 6 square minus 4 times 1 times 13, which is less than 0. So no roots. So over here I factorized it out. So it will become, so I have to do the partial fractions for this. So it becomes x plus 6 upon x square minus 6x plus 8 equals to a times x minus 4 plus b times x minus 2. So x plus 6 equals to a times x minus 2 plus b times x minus 4. So plug in x equals to 4. So I get 10 equals to 2a, a equals to 5. Then x equals to 2, 8 equals to minus 2b, b equals to negative 4. So what will be this integral will become? 5 upon x minus 4 minus 4 upon x minus 2 dx. So it becomes 5 ln of x minus 4 minus 4 ln of x minus 2 plus c. If you want to further factorize it out, alright, x minus 4 whole to the power of 5 divided by x minus 2 whole to the power of 4 plus c. Question number 16. Calculate the integral of this. So what am I going to do? This negative x square, negative 6x plus 7, directly I am writing it out. You can factorize it out and write as negative of x plus 3 whole square plus 16. So it becomes 7 integral of square root of 16 minus x plus 3 whole square dx. So it is sine inverse formula. 7 sine inverse of x plus 3 upon 4 plus c. Question number 17. By using long division or otherwise, find this one in this form. So 3x square plus 4x plus 2 divided by x square minus 6x plus 8. So I have to write in the form of the denominator so that denominator can get cancels. 6x plus 8 plus 3 times x square is 3x square, then 3 times minus 6x is minus 18x, but I want plus 4x. So I should be adding 22x because 22 minus 18 will become 4. Next is 3 times 8 is 24, but I want 2. 24, I am writing 24, but I want 2. So I subtract 22. 24 minus 22 divided by x square minus 6x plus 8. Now separate this as a fraction. 3 times of x square minus 6x plus 8 divided by x square minus 6x plus 8 plus 22x minus 22 divided by x square minus 6x plus 8. Now what I will do, I'll take this part and do partial fractions. 22x minus 22 divided by x square minus 6x plus 8. Partial fractions for that one will become a upon x minus 2 plus b upon x minus 4. 22x minus 22 equals to a times x minus 4 plus b times x minus 2. So for that, x equals to 2 gives me 22 equals to negative 2a, a equals to negative 11, and x equals to 4, 66 equals to 2b, b equals to 33. Then I got the partial fraction, so this entire question can be written as now. This gets cancelled, so integral of 3 plus a upon a is 33 upon x minus 4, b is minus 11 upon x minus 2 dx. So what will be the answer? 3x plus 33 ln of x minus 4 minus 11 ln of x minus 2 plus c. That's going to be the answer. Now question number 18. Use the substitution u equal to tan x to find the definite integral. So u equals to tan x. So du equals to secant square x dx. So what does the first part will become? U to the power of 5 du. So which will become u to the power of 6 upon 6 plus c, which is tan x whole to the power of 6 upon 6 plus c. Second part will become du upon square root of u. So u to the power of negative half du. So it will become u to the power of half upon half plus c. So 2 square root of u plus c. So which will become 2 square root of tan x plus c. Now coming to part 3, it will become du upon e to the power of u. So it becomes e power negative u du. So it becomes e power negative u upon negative 1 plus c. So negative e power negative tan x plus c. And for finally the part 4, it becomes, how should I be writing? It can be written as sine to the power of 5x by cos to the power of 5x times 1 upon cos to the power of 2x. So it becomes tan to the power of 5x times secant square x dx. So which will become again nothing but what? U to the power of 5 du. So will become u to the power of 6 upon 6 plus c, which is tan to the power of 6x upon 6 plus c. Question number 19. So we can see that this is a formula. What is a special formula? If there is a function in the denominator, its derivative is in the numerator, then ln denominator is going to be the formula. So tan x can be written as sin x upon cos x. Cos x derivative, what is cos x derivative? Minus sin x. So minus is missing, so I introduced minus. So it becomes ln cos x, but that extra minus is there outside, so minus ln cos x. Cot x can be written as sin x upon cos x. We can clearly see cos x upon sin x. Cos x upon sin x. We can clearly see that sin x derivative is cos x, so directly ln sin x plus c. Now we can clearly see that x square derivative 2x is there, so ln x square plus 7 plus c. 3x square derivative is 6x. 6 is missing, So what should I be doing it out? I will be multiplying and dividing by 6. So it becomes 1 upon 6 ln of 3x square plus 7 plus c. 3x cube derivative is 9x cube. 9x square. 9 is missing. 1 multiply and divide by 9. Ln of 3x cube plus 7. 3x square plus 5x plus 1 derivative is 6x plus 5. So everything is present. So no need to multiply and divide by anything. This is going to be the answer. E power x derivative is e power x only. So it's going to be ln of e power x plus 5 plus c. E power 2x derivative is 2 e power 2x. So 2 is missing. So 1 upon 2 ln of e power 2x plus 5 plus c. Question number 20. Now using the substitution u equals to e power x. So du equals to e power x dx. So this will become du upon u square plus 1. So this is 1 upon a tan inverse of u upon 1 plus c. So tan inverse of e power x plus c. Question number 21. Use the substitution u equals to x plus 5. So u equals to x plus 5. So du equals to dx. And another is x is u minus 5. So what will be the first one? First one will be 3x. 3xx is u minus 5 divided by u times dx is du. So it becomes 3 u upon u is u upon u minus 5 upon u du. So what does it, that becomes integral of 3 du minus integral of 15 upon u du. So it will become 3u minus 15 ln u plus c. So 3 times of x plus 5 minus 15 times of ln x plus 5 plus c. Coming to the second part. Second part, x. What is x? X is u minus 5 and square root of u du. So it becomes u upon u is square root of u minus 5 u to the power of minus 1 by 2 du. So this becomes u power 3 upon 2 upon 3 upon 2, 5 u power 1 upon 2 upon 1 upon 2 plus c. So this becomes 2 upon 3, x plus 5 whole to the power of 3 upon 2 minus 10 square root of x plus 5 plus c. Coming to the third part. This is u square means x square means u minus 5 whole square divided by u du. So it will become integral of u square minus 10u plus 25 divided by u du. So it will become u minus 10 plus 25 upon u du. So it becomes u square upon 2 minus 10u plus 25 ln u plus c. So what is that answer? X plus 5 whole square upon 2 minus 10 times of x plus 5 plus 25 ln of x plus 5 plus c. Question number 22. Use the substitution u equals to x square plus 5. So u equals to x square plus 5. So du equals to 2x dx. So x dx equals to du upon 2. And again x square equals to u minus 5. So what is that? Now first one, for the first one, integral of, what am I going to write it out? I have x square and x cube. X cube can be written as x square times x square plus 5 whole to the power of 5 times x dx. So you can clearly see that x cube can be written as x square times x. Now that what is x square becomes u minus 5 and x square will become u minus 5, and this becomes u power 5 times x dx is nothing but what? Du upon 2. So 1 upon 2 integral of u power 6 minus 5 u power 5 du. So it becomes 1 upon 2 u power 7 upon 7 minus 5 u power 6 upon 6 plus c. What is u? U is x square plus 5 whole to the power of 7 upon 14 minus 5 x square plus 5 whole to the power of 6 upon 12 plus c. That is the first part. Now coming to the second part. For the second part, it is x cube. X cube can be written as x square times x dx upon square root of x square plus 5. X square is u minus 5. X dx is nothing but what? Du upon 2 and by square root of u. So what does that becomes now? 1 upon 2 integral of u to the power of minus u to the power of half 5 u to the power of negative half du. So this will become 1 upon 2 u power 3 upon 2 upon 3 upon 2 minus 5 u to the power of 1 upon 2 upon 1 upon 2 plus c. So it becomes 1 upon 3 x square plus 5 whole power 3 upon 2 minus 5 square root of x square plus 5 plus c. Then coming to the third part, x power 5 by x square plus 5. X power 5 can be written as integral of x square whole square times x dx divided by x square plus 5. X square is nothing but what? U minus 5 whole square. X dx is du by 2 divided by u. So it becomes 1 upon 2 u square minus 10u plus 25 divided by u du. So it becomes 1 upon 2 u minus 10 plus 25 upon u du. So what will be the answer? 1 upon 2 u square upon 2 minus 10u plus 25 ln u plus c. And now what is u value? So x square plus 5 whole square upon 4 minus 5 times x square plus 5 plus 25 upon 2 ln of x square plus 5 plus c. Now here be careful, what am I doing it out is, you can leave it out over here or you can further simplify or just leave it out over here for the moment. Question number 23. U equals to sin x. So du equals to cos x dx. So cos cube x can be written as cos square x times cos x dx. So which is use again cos square x can be written as 1 minus sin square x times cos x dx. So it becomes 1 minus u square times du. So it becomes u minus u cube by 3 plus c. So which is sin x minus sin cube x upon 3 plus c. Coming to the second part, cos to the power of 5 can be written as cos square x whole square times cos x dx. So which is nothing but what? 1 minus sin square x whole square times cos x dx. So it becomes 1 minus u square whole square times du. So it becomes 1 minus 2u square plus u power 4 du. So it becomes u minus 2u cube by 3 plus u power 5 upon 5 plus c. So what is that? The answer is going to be sin x minus 2 sin cube x upon 3 plus sine to the power of 5x upon 5 plus c. Coming to the third part, sine square x cos cube x. Sine square x cos cube x. Cos cube x can be written as cos square x times cos x dx. Again, cos square x can be written as 1 minus sine square x times cos x dx. What is sine square x? U square, 1 minus u square du. So it becomes u square minus u power 4 du. So it becomes u cube by 3 minus u power 5 upon 5 plus c. So which is sine cube x upon 3 minus sine to the power of 5x upon 5 plus c. Now coming to question number 24. X equals to 3 tan theta. So dx equals to 3 secant square theta d theta. So this will become 3 secant square theta d theta divided by 9 plus 9 tan square theta. So 3 secant square theta, 9 common, 1 plus tan square theta d theta. Secant square theta and 1 plus tan square theta are same, they get cancels. 3 times 1, 3 times 3. So I'm left over with 1 upon 3, 1 d theta, 1 upon 3 theta plus c. What is theta? From here, tan theta equals to x by 3. So theta equals to tan inverse x by 3. So it is 1 upon 3 tan inverse x upon 3 plus c. Substitute x equals to 3 sin theta. So dx equals to 3 cos theta d theta, and sin theta equals to x upon 3, theta equals to sin inverse x upon 3. So these are the two results I will be using it out. So dx is 3 cos theta d theta divided by square root of 9 minus 9 sin square theta, then 3 cos theta d theta, take 9 common, square root of 9 is 3, 1 minus sin square theta. 1 minus sin square theta is nothing but what? Cos square theta. Square root of cos square theta. Square root of cos square theta. First 3 cancels. Square and square root gets cancels. Cos theta gets cancelled. So everything is cancelling 1 theta. So theta plus c. Theta is nothing but what? Sine inverse of x upon 3 plus c. So based upon that formula, we can directly write it out over here for question number 26. It is 1 upon a tan inverse of x upon a plus c. For part B, it is 2 is missing, multiply and divide by 2. So 1 upon 2 ln of x square plus 2 plus c. Now part C, x square divided by x square plus 2. So what should I do? Add 2, subtract 2. So that x square plus 2 upon x square plus 2 will become 1 minus 2 upon x square plus 2 dx. So one integral is x, and this one is just nothing but what just now we have done, 2 upon root 2 tan inverse of x upon root 2 plus c. Or D, x cube can be written as x square times x divided by x square plus 2 dx. So substitution, u equals to x square plus 2. So du equals to 2x dx. So 2x dx, multiply and divide by 2. So what does that becomes? 1 upon 2, x square is u minus 2, 2x dx is du divided by u. So it becomes 1 upon 2, u upon u is 1 minus 2 upon u du. So 1 upon 2 u minus 2 ln u plus c. So 1 upon 2 u is x square plus 2 minus 2 ln of x square plus 2 plus c. Question number 27. Use the appropriate substitution. So u equals to ln y. So du equals to 1 upon y dy. So it becomes integral of tan u du. So integral of tan u is nothing but what? Minus ln of cos u plus c. So minus ln of cos u. U is nothing but what? Ln y plus c. By using an appropriate substitution, solve this one. So in the same way, u equals to ln y. So du equals to 1 upon y dy. So it will become cot u du. Cot u is nothing but what? Ln sin u plus c. Ln sin u. U is nothing but what? Ln y plus c. By using the substitution, y equals to 2 minus x. So dy equals to minus dx. So x equals to 2 minus y. So these are the two substitutions I am going to do. So what does it becomes? X is 2 minus y divided by 2 minus x is y whole square. Dx is minus dy. So it becomes minus of 4 minus 4y plus y square divided by y square dy. So minus of 4 upon y square minus 4 upon y plus y square by y square is 1 dy. Now what should be that? It becomes minus integral of 4y to the power of minus 2 dy plus 4 1 upon y dy minus 1 dy. So what should be the answer? Minus 4y to the power of minus 1 upon minus 1 plus 4 ln y minus y plus c. So it becomes 4 upon y, which is 2 upon x, plus 4 ln 2 minus x minus 2 minus x plus c. Question number 30. Find the integral u equals to half x plus 1. So u equals to half x plus 1. So du equals to half dx. Then again half x equals, so dx equals to 2 du. That is a substitution. Dx equals to 2 du. That is one substitution I'm going to do. Then half x equals to u minus 1. X equals to 2u minus 2. That is another substitution I'm going to use. Now what am I going to find? Integral of x square root of half x plus 1 dx. So x is nothing but what? 2u minus 2. Then square root of u times dx is nothing but what? 2 du. So it becomes, what can I do is I can take 2 common and that multiplied with this 2 will become 4. 4 times u root 2 is u power 3 by 2. Then this is 1 times root u is u power 1 upon 2 du. So 4 times u power 5 upon 2 upon 5 upon 2 minus u power 3 upon 2 upon 3 upon 2 plus c. So what does it becomes? 8 upon 5 u. What is u? Half x plus 1 whole power 5 upon 2. Then minus 8 upon 3 half x plus 1 whole power 3 upon 2 plus c. Question number 31. U equals to x plus 2. So du equals to dx and x equals to u minus 2. These are the two substitutions I will be using. So it will become x cube, which is u minus 2 whole cube by u square du. So u minus 2 whole cube is u cube minus 6u square plus 12u minus 8 divided by u square du. So u cube by u square is u minus 6 plus 12 upon u minus 8 upon u square du. So integral will be u square upon 2 minus 6u plus 12 on u minus 8 u power minus 1 upon minus 1 plus c. So u is nothing but what? X plus 2 whole square upon 2. 6 times x plus 2 plus 12 on x plus 2 plus 8 upon x plus 2 plus c. Question number 32. Substitution x equals to root 5 sine theta. So dx equals to root 5 cos theta d theta. So it becomes square root of 5 minus 5 sine square theta times dx. Dx is root 5 cos theta d theta. So I can take 5 common, so that comes outside as root 5. I'm left over with 1 minus sine square theta times this root 5 cos theta d theta will be left over. So 5 times root 5 is 5. Square root of 1 minus sine square theta is square root of cos theta d theta. Square and square root gets cancels. Cos theta times cos theta is nothing but what? Cos square theta. 5 integral of cos square theta d theta. What should I do for this cos square theta d theta? We know from formula booklet cos 2 theta is 2 cos square theta minus 1. So 2 cos square theta equals to 1 plus cos 2 theta. So cos square theta equals to 1 plus cos 2 theta divided by 2. So it will become 5 times 1 plus cos 2 theta divided by 2 d theta. So 5 upon 2, 1 integral is theta, cos 2 theta integral is sin 2 theta by 2 plus c. So what is theta? Theta is sin inverse of x upon root 5 plus 5 upon 4 sin 2 theta. What is sin 2 theta? Sin 2 theta is 2 sin theta cos theta plus c. So I add a page over here because it requires somewhat working. So 5 upon 2 sin inverse of x upon root 5 plus 5 upon 2 sin theta. Sin theta, what is sin theta? Sin theta is x upon root 5 cos theta. Cos theta is 1 minus sin square theta, 1 minus x square upon 5 plus c. We can leave it off over here, or else we can further simplify out 5 upon 2 sin inverse of x upon root 5 plus 5 root 5 and 5 gets cancelled. It will be root 5 upon 2 and square root of 5 minus x square upon root 5, this one over here, plus c. Again root 5 can be cancelled and this x is also there. So my final answer will be, so you have to be very much careful with this question, sin inverse of x upon root 5 plus x square root of 5 minus x square upon 2 plus c. Question, so 36 questions are there. We are in question number 33, just 3 more questions, then we'll complete this video. Now x equals to 4 sine square theta. So dx equals to 8 sine theta. Sine theta derivative is cos theta d theta. So now substitute x is square root of x, which is 4 sine square theta divided by 4 minus 4 sine square theta times dx. What was dx? Dx is 8 sine theta cos theta d theta. 4 cancels. So what am I left over with? Square root of sine square theta is sine theta. 1 minus sine square theta is cos square theta. Square root of cos square theta is cos theta. Or else I will write the steps over here. Square root of sine square theta divided by 1 minus sine square theta times 8 sine theta cos theta d theta. So square root of sine square theta by cos square theta. Sine square theta by cos square theta, 8 sine theta cos theta d theta. Square and square root gets cancels. Then cos theta gets cancels. So I am left over with 8 integral of sine square theta d theta. So again from formula booklet, cos 2 theta equals to 1 minus 2 sine square theta. So 2 sine square theta equals to 1 minus cos 2 theta. So sine square theta equals to 1 minus cos 2 theta divided by 2. So it becomes 8, 1 minus cos 2 theta divided by 2 d theta. So it becomes 4, 1 minus cos 2 theta d theta. So it becomes 4 theta minus sine 2 theta by 2 plus c. So I add a page over here again. So what was the formula? 4 theta minus 2 sine 2 theta plus c. 4 theta minus 2 sine 2 theta is 2 sine theta cos theta plus c. So 4 theta minus 4 sine theta cos theta plus c. 4 theta. Theta is nothing but what? Sine inverse of root x upon 2. Why? Because our substitution was, what was the substitution? X equals to 4 sine square theta. So what is sine square theta? X upon 4. So sine theta equals to square root of x upon 2. So theta equals to sine inverse of square root of x upon 2. So that only has been substituted over here. Minus 4 sine theta. What is sine theta? Square root of x upon 2. Cos theta 1 minus sine square theta plus c. So it becomes 4 sine inverse of square root of x upon 2 minus 2 square root of x square root of 4 minus x upon 4 plus c. So it becomes 4 sine inverse of square root of x upon 2 minus 2 square root of x square root of 4 minus x upon 2 plus c. 2 cancels. This is going to be your final answer. Question number 34. Show that. So I take the left hand side and get the right hand side. So x square plus 4 minus x times x minus 2 divided by x minus 2 times x square plus 4. So it becomes x square plus 4 minus x square plus 2x divided by x minus 2 times x square plus 4. X square cancels and we get the answer. So now the integral will be integral of 1 upon x minus 2 minus x upon x square plus 4 dx. So this becomes ln of x minus 2 minus, you can see that 2 is missing. So it becomes 1 upon 2 ln of x square plus 4 plus c. Next question number 35. So integral of e power x upon e power x is 1 plus e power 1 upon e power minus x is minus e power x dx. So it becomes x minus e power minus x plus c. Now again it is in the formula. Derivative of denominator is present in the numerator. So this can be written as ln of denominator plus 1 plus c. Now e power u equals to, you can do as u equals to e power x. So du equals to e power x dx. So it becomes du upon u square plus 4. 4 is 2 square. So 1 upon a tan inverse of x upon a. So 1 upon 2 tan inverse of e power x upon 2 plus c. Now 3 power x equals to u. So 3 power x ln 3 du dx equals to du. So this way, if at all I do it out, this will be 3 power x ln 3 dx equals to du. So 3 power x dx equals to 1 upon ln 3 du. So this will become 1 upon ln 3 du divided by u square plus 3 square. 9 power x is u square. So this will become 1 upon ln 3, 1 upon a tan inverse of x upon a, u upon 3 plus c. So 1 upon 3 ln 3 tan inverse of u is nothing but what? 3 power x upon 3 plus c. Next, 2x equals to sine theta. Then otherwise find square root of 1 minus 4x square. So what is the substitution? 2x equals to sine theta. So 2 dx equals to cos theta d theta. So dx equals to 1 upon 2 cos theta d theta. So it becomes square root of 1 minus 4x square, which is sine square theta. Dx is 1 upon 2 cos theta d theta. So 1 upon 2, 1 minus cos square theta is sine square theta is cos square theta. Then cos theta d theta. Square and square root gets cancelled, so I will be left over with 1 upon 2 cos square theta d theta. Just now we learnt a formula. Cos square theta is 1 plus cos 2 theta divided by 2. That formula in the previous question we have done. 1 plus cos 2 theta divided by 2 d theta. So 1 upon 4, 1 integral is theta, cos 2 theta integral is sin 2 theta by 2. So it becomes theta by 4 plus 1 upon 8, sin 2 theta is 2 sin theta cos theta plus c. So theta, what is theta? Theta is sine inverse of 2x. So this is sine inverse of 2x divided by 4 plus 1 upon 4 sine theta. Sine theta is 2x, cos theta is 1 minus sine square theta plus c. So my final answer is sine inverse of 2x upon 4 plus 1 upon 2 x square root of 1 minus 4x square plus c. Next, integral of sine cube x. So let u equals to cos x. So du equals to minus sin x dx minus. So sine cube x can be written as sine square x times sin x dx. But minus is missing. So minus over here and minus over here. So what does that becomes now? Minus integral of u square is sin square x is 1 minus cos square x, and this is nothing but what? Du. So it becomes integral of u square minus 1 du, which becomes u cube by 3 minus u plus c. So which is nothing but what? Cos cube x by 3 minus cos x plus c. Now to the next question, u equals to sin x is a substitution. So du equals to cos x dx. So sin cube x, then cos square x times cos x dx. Sin cube x is nothing but what? U cube. Cos square x is 1 minus sin square x, and cos x dx is du. So it becomes u cube minus u power 5 du. So this becomes u power 4 upon 4 minus u power 6 upon 6 plus c, which is sin 4x upon 4 minus sin power 6x upon 6 plus c. Now this is 1 upon a tan inverse of x upon a. The limits are 0 to 2. Substitute upper limit, it becomes tan inverse of 2 upon 2 minus tan inverse of 0 upon 2. Tan inverse of 1 is pi by 4, tan inverse of 0 is 0. So pi by 8. Then 1 upon a tan inverse of x upon a from 0 to k is pi by 6. So tan inverse of x upon 2 from 0 to k is pi by 3. The 2 goes to the other side, it becomes pi by 3. So it becomes tan inverse k by 2 minus tan inverse of 0 equals to pi by 3. Tan inverse of 0 is 0. Tan inverse of k by 2 equals to pi by 3. K upon 2 equals to tan pi by 3. What is tan pi by 3? Tan pi by 3 is tan 60 is root 3. So k equals to 2 root 3. Now 1 upon 1 plus x square. is nothing but what? 1 upon a tan inverse of x by a equals to 0.22 from the limit 0 to a square. From the limits a to a square. So tan inverse of a square minus tan inverse of a equals to 0.22. Tan inverse of a square minus tan inverse of a equals to 0.22. So this one we have to do by GDC itself only. Use the GDC, and by using the equation solver you will be getting the value of a as 2.04 or a as 2.62. Now u equals to e power x, so du equals to e power x dx. So first of all I do with definite integrals, so it will become du upon u square plus 9. So it is 1 upon a tan inverse of u upon 3 plus c, but I am converting into e power x, so e power x upon 3 plus c. Now I want definite integrals, so it will become 0 to ln 3 e power x dx upon e power 2x plus 9 will become 1 upon 3 tan inverse e power x upon 3 from 0 to ln 3, plus c is not required. So it becomes 1 upon 3 tan inverse of e power ln 3 upon 3 minus tan inverse of e power 0 upon 3. So this is 1 upon 3 tan inverse of e power ln 3 is 3. 3 by 3 is 1 minus tan inverse of 1 upon 3. So what is it becomes? 1 upon 3 tan inverse of 1 is pi by 4 minus tan inverse of 1 upon 3. So my final answer is pi by 12 minus 1 upon 3 tan inverse of 1 upon 3. X equals to 2 sine theta. So dx equals to 2 cos theta d theta. Change the limits. Lower limit. X equals to, these are limits of x. So 0 equals to 2 sine theta. Last time I have done without changing the limits. Better to change the limits. So theta equals to 0. Upper limit 2 equals to 2 sine theta. Sine theta equals to 1. So theta equals to pi by 2. So it will become 0 to pi by 2 square root of 4 minus 4 sine square theta dx is nothing but what? 2 cos theta d theta. So this 4 common, square root of 4 is 2, that 2 will get multiplied with this 2 and it becomes 4, and I'm left over with 1 minus sine square theta times cos theta d theta. 1 minus sine square theta is cos square theta. Square root of cos square theta is cos theta. Cos theta times cos theta is cos square theta. And 1 plus cos 2 theta divided by 2 d theta. So 2 times 1 plus cos 2 theta d theta. So 2 times theta plus sin 2 theta by 2 plus c. So it becomes as 2 theta plus sin 2 theta plus c. 2 theta plus 2 sin theta cos theta plus c. 2 theta. What is theta? Theta is sine inverse of, now plus c is not required because these are all definite integrals, so therefore I will not be doing plus c, rather than I will be substituting the limits. What are the limits? 0 to pi by 2. 0 to pi by 2 are the limits. That is the easiest way. 0 to pi by 2. 0 to pi by 2. 0 to pi by 2 and 0 to pi by 2. So substitute pi by 2. So it will become 2 pi by 2 time plus sine of 2 times pi by 2 minus 2 times 0, 0 plus sine of 0. So it becomes pi plus sine pi minus 0. So sine pi is 0 minus 0. So answer is going to be pi. Question number 46, and that's the last question. So x equals to sine square theta, x equals to sine square theta. So dx equals to 2 sine theta cos theta. Then lower limit 0 equals to sine square theta. So sine theta equals to 0, theta equals to 0. Then 1 by 2 equals to sine square theta, which is upper limit. Sine theta equals to 1 by root 2, theta equals to pi by 4. 0 to pi by 4, square root of sine square theta by 1 minus sine square theta, dx is 2 sine theta cos theta d theta. Square and square root gets cancels. 1 minus sine square theta is cos square theta. Again square and square root gets cancels. So 0 to pi by 4 sine theta by cos theta times 2 sine theta cos theta d theta. Then cos theta cancels. 2 is a number outside. Sine theta times sine theta is sine square theta d theta. 2 1 minus cos 2 theta by 2 d theta. So 2 cancels. One integral is theta. Cos 2 theta integral is sine 2 theta by 2. Then don't forget to write the limits 0 to pi by 2. 0 to pi by 2. 0 to pi by 2. Now substitute pi by 2 minus 1 by 2 sine pi minus 0 minus sine 0. Pi by 2 sine pi is 0 and the limits are 0 to pi by 4, not pi by 2, pi by 4. The limits are 0 to pi by 4. So what am I going to do that? I am going to replace it with 0 to pi by 4. So upper limit is pi by 4 minus sine of 2 times pi by 4 is pi by 2 minus substitute the lower limit 0 minus sine 0 by 2. So it becomes pi by 4 sine pi by 2 minus 0. Pi by 4 sine pi by 2 is 1 by 2. Pi by 4 minus 1 by 2. That's going to be the answer. So that completes the video. See you in the next video. Bye.